Okay, so for even and odd functions, that looks terrible. For even and odd functions, I'm going to show you the meaning, the mathematical derivation, and then just kind of the layman's terms, simple way to remember even and odd functions. So let's start with what even functions mean. If a function is even, that means it's symmetrical about the y-axis. So that means if I would draw a curve, this is symmetrical about the y-axis, meaning if I pick this point, it is the same distance away from this point opposite it. It's like a perfect line of symmetry. So that's how you can remember an even function. It's always symmetric about the y-axis. An odd function is symmetric about the origin. So let's kind of write that down. This is symmetric about the y-axis. And this is symmetric about the origin. And so let me put a common odd function on there. Let's not use red, let's use purple. And so you can see, if I pick this point, it is the same distance away from the origin as the same point over here. Those 2 points opposite each other, they're symmetric about the origin. They're the same distance away from the origin. And so you need to be able to determine if a function is even or odd based upon looking at a graph or looking at a function. Most common with us in my class, it'll be given a function, determine if the function's even or odd. So I'm going to show you the mathematical derivation first, and then at the end I'll kind of give you just an easy way to figure it out. So, even functions are if you have some function, and if you make all of the x's negative, then the result will be your original function. And I'll show you what I mean by that. So let's say I have the function x squared. We'll just start simple. F of x equals x squared. If I do f of negative x, meaning anywhere I see an x I make it negative, I should end up with the same result as my original. And so let's see. Negative x times negative x is just x squared. So you can see how my result is the same as my original function. They're identical. They're both x squared. Let's try it with something maybe a little more difficult. Let's say f of x equals x to the fourth plus x squared plus 2. So again, to see if it's an even function, we're going to make all of our x's negative and see if we get this exact same expression as our original function. So let's see, negative x to the fourth plus negative x squared plus 2. Well, negative x times negative x is x squared, times negative x is x cubed, times negative x is x to the fourth. And we already know that negative x times negative x is x squared. The 2 doesn't change. You can see that even when I make all the x's negative, I end up with the exact same expression. They're identical. When that happens, it's an even function. Let's look at an odd function. We'll start again with the rule. If your original function if you make all the x's negative in an odd function, it'll end up being the negative of your original function. So it would be essentially the exact opposite. And so again, let's start with an example. If f of x equals x cubed, if I take f of negative x, so I make my x negative, negative x times negative x is x squared, times negative x is negative x cubed. And so you can see that these are exact opposites My original function is x cubed. My end function is the opposite of that, negative of that function. And so that's what we're looking for when we do an odd function. Let's do one maybe a little more complicated. Let's say we got x to the fifth plus x cubed. I want to make my x's negative. And again, we've already saw that this equals negative x cubed. And negative x times negative x is x squared, times negative x is negative x cubed, times negative x is positive x to the fourth, times negative x is negative x to the fifth. So again, our end result here is the exact opposite. See, it was positive here, now it's negative. It was positive here, now it's negative. It's the exact opposite of our original function. That makes it odd when it occurs. Now, just because you have even exponents, odd exponents, doesn't mean it's always going to be even or odd. In fact, most of the time, it'll be neither. So let's do an example of neither. Let's do x squared plus x plus... x squared plus x plus 1. And again, if that's what f of x equals, we're going to make all of our x's negative. So what would that look like? Negative x squared plus negative x plus 1. Negative x times negative x is x squared, plus negative x is just minus x plus 1. So now, we either want it to be exactly the same as our original or exactly opposite. So this was positive. This one's positive. So far it looks like we've already ruled out that it cannot be odd, because the x squared and would have to be negative x squared for it to be odd. So we've already ruled out that it can't be odd. Let's look to the x. It's positive here, but it's negative here. So that means it can't be even. It's not exactly the same. It's not exactly opposite. So it's neither. So I want you to be able to know the rule here. I just want to summarize these rules. That if you do f of negative x and it gives you your original function, then it's even. If you do f of negative x and it gives you the opposite of your original function, then it's odd. And if neither of those happen, then it's neither, obviously. So if you don't like that, I want you to know the rules, because this might show up on like an ACT. They might not give you an actual expression. They might just put it in like function notation. And so I want you to know those rules. However, for the sake of my tests and any other kind of more real life example, I'm going to give you the easy way to see this. The first thing to be able to do this, the quote easy way, is we're going to treat non-variables we call those constants. We are going to treat those like even exponents, meaning, technically it's to the 0. We're going to treat 0 like an even number, exponent. And that allows us to do this rule. So put a big asterisk here. If all variables have even exponent, then it's even. If all variables have odd exponents, then it's odd. If there's a mix, then it's neither. So I'll show you what I mean by that. Let's take a look at this example. F of x equals x to the 6th plus x to the 4th plus x squared. Well, all of these variables have even exponents, so this is going to be an even function. And to show you with the math that it works, if I make all of my x's negative, I will end up with the exact same function as my original, which is the rule for even. Let's take a look at another one. All of my variables have odd exponents, so it's odd. And again, if I make all my x's negative, I end up with negative x to the 9th minus x to the 5th minus x cubed. It is exactly opposite. It was positive up here, it's negative down here. Positive up here, negative down here, positive up here, negative down here. It's odd. What about this one? Pause it and try to figure this one out. Okay, hopefully you pause it and try to figure this out. This is an even function. And hopefully you're asking, well, what about this? It doesn't have an even or an odd. It's just a constant. Well, remember, I told you we're going to treat constants as if they have an even exponent. And so when we do that, even function. Whereas if we look at a very typical x cubed plus x plus 1, odd, that has an exponent of 1, so it's odd, but this is even, so it's a mixture, so it's neither odd nor even. Okay, so I've kind of showed you the mathematical derivation, kind of the easier way to memorize it. Hopefully you don't have any problems with this. If you have any questions, let me know. Bye.